Now let's discuss how to write a program to check a number is an Armstrong number or not. Okay, so here most of us think the logic of Armstrong number is sum of the cube of the given digits is equal to the input value. If both are same, I can say that it is an Armstrong number, else it is not an Armstrong number. Actually, that is not the correct logic. So here if I take the input value 153, 1 cube plus 5 cube plus 3 cube. So the value is 1 cube value is 1, 5 cube value is 125, 3 cube value is 27. So final value will be 153. So this value and the input value both are same, so I can say that it's an Armstrong number. So most of us are thinking that sum of the cube of the given digits. Actually, this is not the correct logic. The correct logic is based on the number of digits I have to raise the power value. This is the correct logic. For example, if I give the input values 1634, I have to raise 1 power 4 plus 6 power 4 plus 3 power 4 plus 4 power 4. Okay, based on the number of digits I have to raise the power value. It's not that always I have to give the power value as 3. Based on the number of digits I have to raise. So 1 power 4 the value is 1, 6 power 4 the value is, so let's check what is the value. So 6 power 4, 6 into 6 into 6 into 6. See 1296. 1296 plus 3 power 4 value is 81 plus 4 power 4 value is 256. If I add all the value, I'll get the value as 1634. So the sum value and the input value both are same. So I can say that it is an Armstrong number. This is the correct logic. So to write this program, first I need to find the number of digits. How can I find the number of digits? Very simple. Take this value, remove one digit. When you are removing one digit, add a variable so that you can get to know the number of digits. Fine, we'll start the program. Hash include stdio.h int main. Fine, I'll take a variable n. So the input will be stored in the variable called n, ampersand n. What I'm going to do is I'm going to copy the input variable in temp, because after finding the number of digits, the input value n becomes 0. Okay, so that is why I'm copying the input value in a variable called temp. So here I'm going to declare one more variable called count is equal to 0, because to find the number of digits of a number. So I'll take a while loop n not equal to 0. Let's assume the n value is 1634. So let me give the input value n to be 1634. I'm going to find the number of digits. So for that n equal to n divided by 10. So 1634 divided by 10, it becomes 163. I have removed one digit, so count value will be incremented. Then go for the next iteration. 163 not equal to 0, condition is true. I'll go here. 163 divided by 10, the value becomes 16. So I have removed the digit 3. So count value, previously it was 1, now it becomes 2. Then go to next iteration, n value becomes 16. 16 modulus 16 divided by 10, the value becomes 1. I have removed the digit 6. So count value will be incremented by 1, which becomes 3. Then n value becomes 1. 1 not equal to 0, yes, condition is true. So 1 divided by 10, the value becomes 0. So I have removed the last digit also. Count value becomes 4. Next I'll go to the next iteration. N value becomes 0. 0 not equal to 0, condition becomes false. I'll come out of the while loop. Now I have got the number of digits, and that has been stored in the variable called count. So count is having the value called 4. So we have got the number of digits. After this, input value n becomes 0, but we need the input value. So I'll copy the input value from temp to the variable n. So I'll take a while loop again, n not equal to 0. So first I have to extract the digit. So input value is 1634. Now I have to extract the digit. How can I extract the digit? Int remainder equal to n modulus 10. So 1634 modulus 10, I'll get the value as 4. Now I have to raise a power value. So for this I'm going to use the function called power. So for that I have to include the header file called math.h. What I'm going to do is sum equal to, so I'll take one more variable called sum to store the sum value. I'll initialize the value as 0. Sum equal to sum plus power of the remainder comma count value. So what is the sum value? 0 plus what is the remainder value? 4. Count value 4. 4 power 4, the value is 256. I'll have the value as 256. Now what I have to do? I have to remove the digit. So n equal to n divided by 10. That is 1634 divided by 10. The value becomes 163. Then I'll go to the next iteration. The n value becomes 163. Check the condition. 163 not equal to 0. Yes, 163 is not equal to 0. I'll go here. 163 modulus 10. I'll get the remainder value as 3. Now what I have to do? Sum equal to sum plus power. Sum value is 256 plus power. I have to find the power value. So that is remainder. What is my remainder value? Well, 3. Count value 4. 3 power 4. 3 power 4. The value is 81. The sum value becomes 337. I'll go here. N equal to n divided by 10. 163 divided by 10. The value becomes 16. Go for the next while loop. N value becomes 16. 16 not equal to 0. Condition is true. I'll go here. I'll extract the last digit. That is 16 modulus 10. The value is 6. Now sum equal to 337 plus remainder comma count. Remainder value is 6. Count value is 4. 6 power 4. The value is 1296. When I add it with 337, I'll get the value as 1296. If I add this, I'll get the value as 1633. Now I have to remove the last digit. 16 divided by 10, the value becomes 1. I'll go to the while loop. The n value becomes 1. 1 not equal to 0. Yes, condition is true. I'll go here. Remainder equal to n modulus 10. So n value is 1. 1 modulus 10. The remainder value is 1. Sum equal to sum plus. Sum value is 1633 plus remainder comma count. Power of remainder comma count. Power value we have to find. So remainder value is 1. Count value is 4. 1 power 4. The value is 1. 1633 plus 1, which is equal to 1634. Now n equal to n by 10. N value is 1. 1 divided by 10. The input value becomes 0. Now go for the while loop again. 0 not equal to 0. Condition becomes false. I'll come out of the while loop. Now I'll check sum value with temp value because input value n becomes 0. So I've copied the value to a variable called temp. That is why I'm comparing with temp. If both are equal, I'll say yes, it is a Armstrong number, else it is not an Armstrong number. I'll print no. Return 0. Let me save this code. Let me run the code now. I'll give 1634. Say yes, it is a Armstrong number. I'll give 123. See, no, it's not an Armstrong number. I'll give 153. Yes, it is an Armstrong number. That's all.